So we've got a rate function for people that enter a line for an escalator. And so from t equals 0 seconds to t equals 300 seconds, the rate at which they enter is 44 times t over 100 cubed times 1 minus t over 300 to the 7th. What a fun equation. That's only valid for 0 to 300. And then for anything greater than 300, after 300, nobody's waiting to get in the escalator ever again. Given some other information, also that as people get on the escalator, they're exiting the line at 0.7 people per second, and also that there are 20 people waiting in line to get on the escalator at time t equals 0. So lots of different things for us to sort of mull over in our brains as we work through this problem. So part A should be the easiest part here. How many people enter the line for the escalator during the time period 0 to 300? Well, if we're given a rate at which they enter the line, the number that enter the line is just our integral from 0 to 300 of that r of t dt function. And you have a calculator for this. This was a calculator problem. And it came out to be, approximately, it came out to be exactly 270. And so this was 2 points, 1 point for having the setup and 1 point for getting 270 people. Everybody good there with part A?
Yep.
Cool. All right, part B also I think was pretty straightforward. Part B says we got this time interval 0 to 300 still. There are always people in line. And we know that, now he wants to look up the same rate equation. We want to know how many people are in the line at t equals 300. Well, the number of people in the line at t equals 300 ought to be the number that there were originally in the line, which would be 20, plus the integral of the rate at which they enter the line, 0 to 300, of r of t dt, which we just found to be 270, minus the integral of the rate at which they exit the line. And if you didn't write this part out as an integral, that's fine. But the rate that they exit the line is 0.7 dt. And so we know that this is then just 20 plus the 270 that enter the line. And then it should be minus 0.7 t from 0 to 300. And 0.7 times 300 should just be 210. So this is 290 minus 210 minus a 0, which is 280. And they gave you 1 point for considering the rate that the people left, and 1 point for the final answer, which means you had to include that initial condition, or else you would have got the wrong answer. You would have got 260. So, and if you didn't write this as an integral, if you just wrote 0.7 times 300, that's also fine. Good or no? Any questions on part B?
Yeah, I had a question. Why isn't the rate of 0.7, why isn't it expressed as 0.7 t? Why is it 0.7 only?
Because it is a constant rate of 0.7, not a constant, and well, it wouldn't be a constant rate if it was 0.7 t. It is a constant rate of 0.7. So when t is 17, it's 0.7 people per second. When t is 1,000, when t is 100, it's 0.7. When t is 38, it's 0.7, right? No matter what t is, it is always 0.7. If t was, if you had 0.7 t, well, then that's not a constant rate of 0.7. That depends on t. That's a linearly increasing rate. But a constant rate means it is a constant. It is a constant function, is just a number.
Oh, so like the equation for that function, like the number of people would be 0.7 t, but the rate would be 0.7.
The rate is 0.7. The number of people that exit the line is 0.7t.
Okay, got it. Thank you.
Yeah, somebody just told me that I don't know why I said, did I say 80? I thought I said 80, but I don't know. Maybe I said 280. I don't know. All these 200s and 20s and all that. 20 plus 270 is 290 minus 210 is definitely 80, not 280. But yeah, the 0.7 is the rate. The rate is 0.7. It's just like here, the rate is 44 times t over 100 cubed times 1 minus t over 300 to the 7th. That's the rate. Well, here the rate is 0.7. So that's the function. Everybody good there with B now? Now that I've not added 200 to my answer for no reason, and now that we've got 0.7 instead of 0.7t. All right, part C. For t greater than 300, we want to know what is the first time that there are no people in line for the escalator. Well, we finished with 80 people at t equals 300. We have 80 people at t equals 300. And we have 0.7 of those people exit the line every second. So just divide that by 0.7. 80 divided by 0.7 gives us 114.286. And then we're talking about at what time t. So this is, we have to add 300 to it because this is after time 300. So we should end up with 414.286. And that was just 1 point for the answer there. Everybody good with part C? Any questions on part C? Divided the 80 by 0.7 because this is the number of people that were in the line. And if I divide that by the rate at which they exit the line, that should tell me how long it takes for them all to leave, right? If I have 80 people, and let's say 80 of them leave per second, we do 80 over 80. Say it takes 1 second. If 40 leave per second, it'd be 80 over 40. 2 seconds for them all to leave the line. Well, it takes each person, we have 0.7 of a person leaves every second, so we divide 80 by 0.7. Does that make sense? All right. Any other questions on C or A, B, or C? Okay. Part D then asks us find the number of people in the line when the number of people in the line is at a minimum. So in order for us to figure out when the number of people in the line is at a minimum, we need to have a function to represent the number of people in the line. Well, the number of people in the line, we'll just call that L, should be equal to the number of people that were in the line at the start, plus the integral of the rate function for them entering the line, 0 to at any t value, 0 to t, they call it r of t, dt, minus the rate at which they leave integrated from 0 to t. So this represents, and we could have put this as one integral point r of t minus 0.7, right? 0 to t of r of t minus 0.7 if we wanted to. Or you could have just written it as 20 plus the integral from 0 to t of r of t dt minus 0.7t outside of the integral, because that's what that integral becomes. However you want to write it. This represents the number of people in the line, right? And so if this is at a minimum, we need to find its derivative and set it equal to 0. Well, the derivative of 20 is 0. The derivative of the integral from 0 to t of a function is just that function, so r of t, and then minus 0.7, and we just set that equal to 0. and you have a calculator, your calculator will tell you that this occurs at t equals 33.013 and t equals 166.575. So there's two options. Our other two options are it could occur at either of the endpoints. So 0, 33.013, 166.575, and 300. All of those are when we could be at a minimum on the interval 0 to 300. We know at 0 there was 20, and we know at 300 there was 80. So now we just need to plug in t equals 33 into our number of people in the line equation. If we do that, we get 3.803. And if we plugged 166 into our integral up there, we end up with 158.070. And it's pretty clear that the minimum then must be 3.803 people. Well, actually, I think they wanted to the nearest number. So nearest whole number 4 people at t equals 33.013 seconds. And the point breakdown for this one is worth 4 points. 1 point if you set r of t minus 0.7 equals 0. 1 point for identifying this value, 33.013, as a possibility. 1 point for the answer, and 1 point for your justification to show that that was the minimum. You could have done a sign chart also. A sign chart would have shown that, but even a sign chart, you'd have to show that since this one was a minimum, but this is also a local minimum, you'd have to show that the value at 33 is less than the value at 300. So just a sign chart wouldn't be good enough. You'd at least need the value here and the value here. Any questions there on part D? So to calculate where r of t minus 0.7 equals 0, is that what you're asking? Yeah. You just graph r of t minus 0.7. So whatever the function was, you just graph 44 times t over 100 to the third times 1 minus t over 300 to the seventh minus 0.7. And then you use your calculator to calculate the x-intercept of it. Does that make sense? Yeah, so it may come out looking like a horizontal line. That's weird. All right. What is our r of t function again? Anybody got it for me here?
It's 44 x over 100 cubed times 1 minus t over 300 to the 7th. X over 300.
To the 7th, right? So,
yes.
And then minus 0.7. Yeah, so I mean, I know this is on Desmos, not on your graphing calculator, but when you plug that in, I mean, I don't know. It looks really flat, so but it does definitely cross through there at some point, 33.013. You probably just need to change your window settings. So then we cross through again at 166.575. So if it looks like a horizontal line, but you know that the window range needs to be from 0 to 300 because that's where you're looking, set your X value range to 0 to 300, and that should help. So, I mean, if you see, you should see on your graphing calculator, when you graph that function, there's an option to just hit window, right? I think it just says window up there, and then you can just change it so that the X min is 0 and the X max is 300, and that should make it look less like a horizontal line. So for 2 or 3 of you that were saying that it came out weird, does that help? Okay, yeah. Yeah, so anytime you're trying to graph some sort of weird function on your graphing calculator, and there is a restriction on the domain of what you're supposed to be looking for, like we are only looking for 0 to 300, don't just let it set the window to 0 to 10 or negative 10 to 10 like it normally does, because that may make the graph look weird. I mean, it shows you an accurate representation of what the graph looks like from negative 10 to 10, which looks like a horizontal line. But we don't care about negative 10 to 10. We care about 0 to 300. So do your best to look at 0 to 300. Cool. All right, everybody good there? Great. Let's go to the grocery store and buy some bananas. So here we've got grocery store opens up. It's got 50 pounds of bananas on a display table. Customers are removing the bananas at this rate for t equals 0 to t equals 12 hours. And then after the store has been open for 3 hours, store employees start adding the bananas back, or adding more bananas to the table at this rate, 3 plus 2.4 natural log t squared plus 2t, from 3 to 12. Only from 3 to 12, because only after 3 hours did they start doing that. So first question they ask us is, how many pounds of bananas are removed from the display table during the first 2 hours? Well, this is the rate at which they're removed. We want to know the actual value, so we just integrate from 0 to 2 f of t dt, which gives you 20.051 pounds of bananas. And that was worth 2 points, one for the integral setup and one for the actual value. Everybody good there with part A? Okay. Part B, find f prime of 7. Well, f prime of 7 should be easy enough to find. You just evaluate the derivative of this at 7. And your calculator will do that for you, and it will give you negative 8.120. I think it says explain what that means in the context of the problem. Well, this is the derivative of the rate, which means it's the rate of change of the rate. So it tells us that, since this is negative, it tells us that the rate the bananas are removed at t equals 7 is decreasing. So that rate is getting slower. They're being removed at a slower rate at t equals 7 than they were just before t equals 7. Slowing down. And this is, it says using correct units. So that would be pounds of bananas per hour per hour. Right? Pounds of bananas per hour is your rate, and then you differentiate that to do pounds of bananas per hour. So the rate at which the rate is changing is negative 8.120. The rate they're being removed is decreasing because the derivative of that rate is negative. Good or no? And 1 point for the value, and 1 point for this description. All right. Part C wants to know, is the number of pounds of bananas on the display table increasing or decreasing at t equals 5? Well, the rate at which the number of pounds is changing is F minus G, right? The rate that they're putting it on, or sorry, the rate that they're being taken, minus the, not F minus G. I had my functions backwards. G minus F, the rate they're being put on, minus the rate they're being taken off. So the rate it's changing at is G minus F, which tells us that if we're looking for is the actual number, the integral of G minus F, increasing or decreasing, it tells us we need to look at G minus F at x equals 5 or t equals 5. So we're just looking for G of 5 minus F of 5 for part C. And G of 5 minus F of 5 is negative 2.263103, which is negative. And so that tells us that the number of pounds is decreasing, because the rate at which it's changing is negative. Right? The amount that is being put onto the table is less than the amount that is being taken off the table. Good or no?
Can we say it as like because f of 5 is larger than g of 5, it's decreasing, or do we have to like actually subtract?
They only, let's see, they associated 2 points. It says considers f of 5 and g of 5. Answer with reason. So I think if you, yeah, I mean, it doesn't specifically give a point for having this value. So if you just said if you said g of 5 is less than f of 5, therefore the rate of change is negative, it's decreasing or something like that, that's probably good enough. Most likely, yeah, I mean, you don't have to have this specific value, so. Is that good or no?
Yes, thank you.
No problem. All right. Okay, part D. Sorry, what did part D ask? How many pounds of bananas are on the display table at t equals 8? So we want to know how many are on there at t equals 8. Well, that ought to be the amount that we started with, which was 50, plus the amount that are put on. And the amount that are put on is the integral of g of t dt. And it said in the first 8, after 8 hours, right? So we're going to 8, but we're starting at 3. Make sure you don't start at 0, because that function is only defined for 3 to 12, right? They only started putting the bananas on at t equals 3. And then we'll subtract from that the integral from 0 to 8 of f of t dt. And so setting up that integral there, well, without the 50, you didn't have to have the 50 to get these 2 points. So using the correct integrals, that's worth 2 points. And then getting the approximate answer of 23.347 from your calculator is the third point for part D. Good or no? Any questions about the bananas?
Is this one only worth 8 points total, or?
No, it was worth 9, 3 there. 1 point for this and 1 point for this, so 4, 5. 6, 7, 8, 9, not 9. 2 for A, 2 for B, 2 for C, and then 3 for D. Any other questions on the bananas? All right. So we've got at least 20 minutes or so here to go over any questions from the definite integrals. If we don't get through all of them, we can always come back to them on Monday if we need to spend a little more time on the definite integrals multiple choice. But I made it through everything anybody asked in the last period, so I think we probably will in this period too. I will work on any questions. So if you want to just start typing questions about definite integrals multiple choice into the chat. Oh my, there's a lot of them there already. Maybe we won't get through them all. So we will start with number 14. And number 14, I did this one last period. This one says, let's let x equal 2 sine theta. And they want you to rewrite the integral from 1 to 2 of root 4 minus x squared over x dx in terms of theta. So this, they're giving you the substitution here, but this substitution that they're doing, there's a lot more questions in this class period than in the, oh my gosh, oh my goodness, there's a lot of questions here. We're not going, there's no way we're going to get through all these. Okay, this type of substitution that they're having you do here is a substitution that in a BC or a Math 151 class, they would just expect that you knew that you needed to make this substitution to evaluate this integral because it's called an inverse trig substitution for integrals and something you learn about. But that's beside the point here. It should be pretty easy to get through this. Anyway, we're going to make x equal to 2 sine theta. So that means that the inside of this integral is going to become the square root of 4 minus 4 sine squared theta over 2 sine theta, if you just replace the x's. But then I also have to replace the dx. So I can find out what dx is by taking the derivative. That should be 2 cosine theta d theta. And I also have to replace these limits of integration, which are x values. So 1 equals 2 sine theta tells me that sine theta is a half, or theta is pi over 6. And if I plug in 2 equals 2 sine theta tells me that sine theta is 1, or theta is pi over 2. And then it's just a matter of simplifying this down. So root 4 minus 4 sine squared theta is root 4 times root 1 minus sine squared theta. And so that'll give me, I cancel these 2's out, that'll give me an integral from pi over 6 to pi over 2 of 2. And then the square root of 1 minus sine squared theta is cosine squared theta using the Pythagorean trig identity. And the square root of cosine squared theta is cosine theta. So I'm going to have a cosine theta up there, which is going to multiply by this other cosine theta, which is cosine squared theta over sine theta. And it looks like that's choice C. Yep. Any questions there on 14? All right. 21. So 21 says we got an integral from pi over 12. That's going to be an issue, to pi over 4 of cosine 2x over sine squared x dx. So this one is one where we're going to sine squared 2x, right? Sine squared 2x. So we're going to have to do a u substitution to get rid of the 2 x's to begin with. And if we let u equal 2x, that means we're going to put a 1/2 and a 2 inside of here. So we're going to have 1/2 of the integral of cosine u du over sine squared u. And we'll double each of these. So pi over 6 makes that a lot nicer. And pi over 2 changes that one also. And then this can be rewritten as cotangent and cosecant if you want to. Or if you don't want to do that, you can also just do another substitution with this. So one way, do this both ways, we could make this 1/2 the integral from pi over 6 to pi over 2 of cotangent u cosecant u du. And the integral of cosecant cotangent should be negative cosecant u. And then the cosecant of pi over 2 is just 1. And the cosecant of pi over 6 is 2. So we'd end up with negative 1/2 times negative 1, which is 1/2. Everybody good there doing it that way? And then the other option would be, we could have let v equal sine u, and then dv would be cosine u du, which would give us 1/2 of an integral. And now we do sine of pi over 6, which would be 1/2, and sine of pi over 2, which would be 1 of, and this would become u to the negative, or not u, so v to the negative 2 dv, or 1 over v squared, which would then integrate to become negative 1 over v. So we'd have the 1/2 negative 1 over v from 1/2 to 1, which would be 1/2 of negative 1 minus a negative 1 over 1/2, which would be minus negative 2, which would be plus 2. And that gives you 1 times 1/2. So either way, you get the same answer. Good with 21? Any questions there on 21? All right, 24. So 24 is very, very similar to the first one we did, 14. It says let x equal tangent theta. And then we want to rewrite 1 to root 3 of the square root of 1 plus x squared dx. So if x is tangent theta, then 1 equals tangent theta. Theta is pi over 4 for our lower limit. Root 3 is tangent theta, means that theta is pi over 3 for our upper limit. And dx is secant squared theta, d-theta, if you take the derivative of that. So we end up with an integral from pi over 3 to pi over 4 of the square root of 1 plus tangent squared theta times secant squared theta d theta. And 1 plus tangent squared using a Pythagorean trig identity is secant squared. the square root of secant squared is secant, and secant times secant squared is secant cubed. Which appears to be choice. Oh, I don't know why I wrote my limits backwards. Right there. Good question. Pi over 4 to pi over. I just did it again, didn't I? No, it should be pi over 4 to pi over 3. I wrote them backwards on this one. Put those ones in the wrong place. 1 to root 3, pi over 4 to pi over 3. Yeah, there we go. You get it or no? All right, 26. All right, 26 gives us this big old chart giving us values of f and f prime. And we want to evaluate the integral from 8 to 0 of f prime of x dx. Well, the integral of f prime is f of x, and we're just going to evaluate that from 8 to 0. So that ought to be f of 0 minus f of 8. And then the chart says f of 0 is 11, and the chart says f of 8 is 7. So 11 minus 7 ought to be 4. Good or no? Any issues there with 26? All right. 27. 27. All right, they've used this annoying notation here. This capital M of 3. And what they're meaning with that notation is this is a midpoint. Nobody uses this notation except for this stupid book that has these questions that I gave you from. This is a midpoint rectangular approximation with 3 subintervals, is what that means. So they want you to approximate, and it's 6x minus x squared, approximate the area of the shaded region from 0 to 6. So we're approximating the integral from 0 to 6 of 6x minus x squared dx using a midpoint Riemann sum. Hold on one second. Okay, sorry about that. All right, so the intervals will be 0 to 2, 2 to 4, and 4 to 6. So our midpoints will be 1. So 6 times 1 is 6 minus 1. And then we got to multiply that by the length of the interval, which is 2. Add to that a midpoint of 3, so that'll be 18 minus 9 times the length of the subinterval, which is 2. And then at 5, it ought to be 30 minus 25 times the length of the subinterval. So 10 plus 18 plus 10. Looks like that ought to come out to be 38. Everybody good with 27 there?
Makes sense.
All right. Let's see here. Number 30. So number 30 says the area for some value of a is 0 to 1, integral 0 to 1 of cosine x dx. And it says they're estimating the value of a using a left, a right, and a trapezoidal approximation with n equal to 100. So going from 0 to 1 of cosine x. And what do we know about cosine x between 0 and pi over 2? Or even 0 to pi, it's a decreasing, but we'll just worry about 0 to pi over 2, right? Pi over 2 is more than 1. So from 0 to 1, this should be a decreasing function. And so a left approximation will overestimate, whereas a right approximation will underestimate. So the left approximation has to be greater than a, which has to be greater than the right approximation. And then the trapezoidal approximation, since this is concave down on this interval, the trapezoidal approximations, anytime we have a concave down function, trapezoidal approximations will be underestimated. So the area has to be greater than t as well. We know the trapezoidal approximation will be better than the right rectangular approximation. So we should be able to say that L is greater than A is greater than T is greater than R. And of course, they wrote them the other way. But still looks like that's choice D, right? They wrote R is less than T is less than A is less than F. But any questions there on 30? All right, 33 is the next one. 33 says the average value of y equals root 64 minus x squared on its domain, which its domain you should be able to find very easily is x is less than or equal to 8, greater than or equal to -8. The average value of it is just the mean value theorem for integrals, so 1 over 8 minus -8. And then the integral from -8 to 8 of that function. Well, that's a function that you're not going to be able to integrate very easily unless you use those substitutions like in 14 and 24, which you don't know how to do. But what you do know is that root 64 minus x squared, at least you should know this, is just a semicircle. It's the upper half of a semicircle. And this is square root of r squared minus x squared. We've talked about this multiple times, and I've even mentioned a few times. This is a semicircle, right? So the integral from -8 to 8 of root 64 minus x squared is just the area underneath that curve. Well, that's just the area of a semicircle. So the integral from -8 to 8 of root 64 minus x squared ought to be 1/2 pi times the radius squared. And so that ought to be 32 pi over 16, which should come out to be 2 pi. I'm pretty good with that, so you got to use a little bit of geometry there to figure out that integral. Any questions on 33? All right, 43. Actually, it's 43 through 46 is the next. So 43, 44, and 45 all deal with the same graph, where this is the point 2, 4, this is the point 0, 2, and this is the point 6, 0. This is the graph of f. So 43 says what's the integral from 0 to 2 of f prime of x dx? Well, the integral of f prime is f of x. Evaluated from 0 to 2 means f of 2 minus f of 0. And f of 2 is 4. F of 0 is 2. So 43 ought to be 2. Oh, f prime of, not f prime of x, f prime of 3x. Shoot. Sorry, I misread that question. I should probably write down the right question. F prime of 3x. So this requires a u substitution. U equal to 3x with a du equal to 3dx. So we'll put 1/3 and a 3. And so now it should be 1/3 of the integral from, and if u is 3, sorry, if x is 0, then u is still 0. But if x is 2, then u is 6. And so now this should be f prime of u du, which should give us 1/3 of f of u from 0 to 6, which is 1/3 of f of 6 is 0, f of 0 is 2, it should be negative 2/3, which is choice B. Any questions there on 43? All right, let's do 44. Do this on the same page since it's using the same graph. 44 says the integral, it says g of x is the integral from 0 to 2x of f of t dt. We want g prime of 1. Well, the derivative of the integral of a function from a constant to 2x should just be that function evaluated at the value of 2x times the derivative of 2x. So g prime is 2f of 2x. We want g prime of 1, which should be 2 times f of 2. F of 2 is 4. So it looks like 44 should be 2 times f of 2, which is 8. Everybody good there with 44? All right. We got time for like 1 or 2 more before we gotta do that retake of that quiz. So number 45 says, what's the next one somebody asked for? H of x is x squared minus f of x. And we want to find the integral from 0 to 6 of h of x dx. So the integral of h of x ought to be the integral from 0 to 6 of x squared minus f of x dx, which is x cubed over 3 minus the integral from 0 to 6 of f of x dx. And the x cubed over 3 will evaluate from 0 to 6 as well. And so this ought to be 6 cubed over 3 is 72. Is that right? Yeah, that's right. Minus 0. And then minus the integral from 0 to 6 of f of x. And again, that's just from this graph. So we would have to figure out what that value was. The integral from 0 to 6 of f of x is just the area of the triangle and the area of the trapezoid together. So base 1 is 2, base 2 is 4, 2 plus 4 is 6, over 2 is 3, times the length there is 2, so that's an area of 6. And this is height times the base here, so this is 4 times 4 is 16, over 2, so that's 14, so 72 minus 14, and that should be 58. Everybody good with 45? Any questions there on 45? All right. I think we will stop there. I know a lot of you asked questions that we did not get to. So I'm going to just take a picture of what we didn't get to. And then we can finish those ones up on Monday, but we gotta end up real quick here so that we have time for the quiz retake for those of you that are doing that.